Welcome to this Lunch and Learn from the Gene Golding Institute. I'm James Thomas. I'm giving the talk today, and hopefully you were expecting me to talk about can others reproduce your results using UV in a Python data analysis project. Outline of the talk today, I'll be talking about this tool that I've mentioned called UV. If you want to search for it online, you have to kind of search for Python UV, because if you search for UV, you get a lot of like Wikipedia articles about ultraviolet light and things like that. So make sure you search for Python UV. And I'll also briefly mention this other tool, which is called pixi, but that's not what we're focusing on today. I'll talk a little bit about why you might want to use those tools, how you might configure them, and then most of the talk will hopefully be a demo that does not go wrong. But it might go wrong because it's a live demo, but that's a bit of fun if it does. Now, I'm not the developer of these tools, so I'm only saying what my experiences of them are. You may have used these tools before and you might know more than me. So if you've got any tips or kind of thoughts, that's welcome. We can have a bit of a discussion at the end. Pau's also popped a link to the tool GitHub page into the chat as well, which is their page. So I'll start by talking about what does UV do. Well, it's very similar to those other tools that you were mentioning in the chat just a second ago. So it's similar to pip, and it's similar to some other tools that are a bit like pip called pip tools or poetry, which sounded like no one here had any experience using. That's completely fine, because I know like there's lots and lots of these tools, and that's one of the problems. It's also similar to venv, which is probably the way that you create a virtual environment when you want to install packages through pip. But what's the difference? How is UV different? Well, it was first released in February last year, so February 2024, and it initially had the functionality of these other tools like venv and pip, but it was basically a bit faster. But one of the things that makes it a little bit different is it actually lets you install Python as well. So these other tools generally require you to have Python installed, and then they work with the version of Python you have installed. You can install UV without having Python at all, and then it can install different versions of Python for you. So you can have more than one version of Python installed. It also, I've put manages your virtual environment. So whereas using the tools like pip or venv, you create your venv, you install packages using pip, you might have a requirements file where you list the requirements, and then you kind of give that to other people to get them to install it. It's all kind of a manual process. You have to go through and like remember to install the requirements, and then you have to remember to update that file. So when you use UV, a lot of this stuff happens automatically, and it uses this thing called a lock file, which we'll come on to later. It sounds a bit kind of mysterious. One of the things that I generally find it's really good at doing is if you're working with somebody else and they don't have Python installed and they don't really know very much about Python, there's a few of the examples we'll come on to later are really good at helping people you're working with install Python and get up and running quickly. So development is really fast paced. There's loads of things you can do. The current version 0.6 was released in February this year, and the most recent release, like updates to the project, was 2 days ago. Now, I've given this talk before, and I've had to update the slides because it changes so frequently. But like the last time I gave this talk, it was updated 5 days before the talk. This time it was updated 2 days before the talk. So you get the idea that kind of it changes fast. Some of the things that kind of set it apart from these other tools is that virtual environments, or we're just going to use the word kind of environments from now on, are really easy and quick to create. Whereas using venv, it can take quite a long time to set a virtual environment up. With UV, it's pretty much instantaneous. So that means that when you use tools like Jupyter Lab, for example, if you want to run notebooks in a browser, say you want to run some tests using PyTest, you can very quickly spin up environments to kind of try out a tool and see whether it's for you. And then you can say, no, I don't want that, and get rid of it. And it doesn't really take any time at all. You can have some, what I've put here is inline script metadata, but what that is just you can have a Python script that contains all of the versions of all the packages it uses within it. And that's really good for recreating bugs or showing demos of different projects with people who don't want to install like lots of versions of different packages. And well, we've got a demo of that in a little bit. It's really useful for tools that help you with your Python project. So if I've got some examples here. Rough, if you've not come across that, is a kind of code formatter and also code checker. So if you've used anything like Black before, which is a thing that formats your code, or you've used something like Pylint, which checks your code for kind of common errors and formatting kind of mistakes, then Rough is a version of that that does all of those things, and it's really easy to use with UV. There's another one there I've put called VisiData, which lets you look at CSV files as if it's sort of a spreadsheet package, but within your terminal. So especially if you're on HPC or accessing a remote system through SSH, and you want to just quickly see what's in a file, it can even kind of plot graphs in the terminal. So it's quite cool. So more on all of that later. But the thing I want to leave you with is that UV is cross-platform, really easy to install and really fast. The other tool I mentioned, which is called Pixi, I'm not going to talk about today, but effectively that is very similar and works for conda. So at the end of this talk, there's some links to that tool as well. So this is where the live demo bit starts and everything might go wrong. But I promised you that I would talk about what lock files are and why you might want to use them. So before we do that, I'd like to do a little bit of motivation of why things can go wrong if you just use pip on its own. So you should be able to see my terminal now. If you can't, just shout in the chat. What I'm going to do is start with a skeleton system that's got Python 3.10 installed, which is a little bit of an old version now, but that's part of the demo. So I can check Python -V, and I can see that, okay, yep, I've got Python 3.10.12 installed. And I'm going to list what's in the directory that I'm in. And I'm going to look at all the files, including hidden files. I've got a folder called .venv, which is what contains the virtual environment. I've already created that. I've got myscript.py, and I've got a requirements.txt. Let's have a quick look at what those things are. So I'm going to cat myscript.py. And I've got the contents of the file here on the screen. So it's just a simple example. I'm not a great statistician, so you might argue that the content of this file isn't very good, but it's just for the purposes of an example. I start by importing a binomial test function from scipy.stats, and then I print a load of messages and effectively do a run that binomial test function with some parameters, and I get a p-value, which if you've ever done statistics, that's a way of seeing how unexpected an outcome is. So in this case, I'm trying to look at, I flipped a coin 10 times, I only observed one head. Do I think the coin might be biased? Let's have a look at the requirements.txt. So cat requirements.txt. That just has 2 lines in. It has NumPy version 1.21.6 and SciPy version 1.7.3, which are the requirements that I need to run the code. So let's get everything set up and test that it works. First, I'm going to activate the virtual environment that I've got. So I'm going to go source.venv/bin/activate. You might have a slightly different way of doing it, but that's fine. Then I'm going to pip install -r from that requirements file. So I'm telling pip to install the requirements from that file rather than me typing them on the command line. So great, I've got internet access. That's good. Pip goes away, it downloads those 2 tools, it installs them and says that it successfully installed them. So now I should be able to run my script. So I can go Python my_script.py. Okay, so no errors. I've got some output here. It's printed all the output I expected, and then it's given me a p-value in the end of 0.021, which means that this is quite unexpected. Maybe the coin is biased. So we're going to remember that number, 0.021. It's going to come up quite a lot. Now let's say in my kind of example project, maybe I want to plot a graph or something like that. And I know that matplotlib, that's the library that you use to do the plotting. So I'm going to think, right, I need to pip install it. So pip install matplotlib. That's what I read to do on some help or something like that, or a tutorial online. That will go off and install matplotlib. And then if you look really closely as the output scrolls by, you'll see that higher up here, NumPy, which we already had, was downloaded. And actually lower down, pip is telling us that it's uninstalled version 1.21.6, which is the version of NumPy we had. and now it's installed version 2.2.4 down here. It gives us a little bit of a warning message that, well, things might not be compatible anymore in red, but I mean, often lots of messages come up and people tend to ignore those things. So anyway, let's just press on and run the script again. So Python, myscript.py. Right, and this is not the output we expected. We get this kind of, especially at this font size, quite difficult to read traceback here. And right at the end, we get some kind of value error is the exception. And it's saying something to do with there's some kind of binary incompatibility. And the reason this is that the version of SciPy that we have installed is no longer compatible with the version of NumPy that pip has just upgraded. And this is the kind of problem that you get when you use pip and you go pip install as we just have done. There is a kind of a workaround to this. So I could edit my requirements file. So I'm going to use nano to edit my requirements file, requirements.txt. This is where we listed all the requirements. I'm going to add matplotlib at the bottom, save and exit. Back at the command line, I'm now going to type again, pip install -r requirements.txt to install from that requirements file. And then pip will now try and download a version of all of those software packages that work together. If I scroll up a little bit, it looks a little bit odd what it was doing. It actually happened, it happened quite quickly. You can see it started by downloading matplotlib 3.10, which is what it wanted. And then it found out that it wasn't compatible. So then it downloaded 3.9.4 and it found out that wasn't compatible. Then it downloaded 3.9.3, 3.9.2, 3.9.1, 3.9.0, and 3.8.4. And eventually it found out, right, I think that one will work. So it's a bit kind of, doesn't seem very efficient that it has to download every version. But let's just verify, does it work now? Python myscript.py. Okay, yeah, we get that same p-value, 0.021. So after a fashion, we've managed to make it work, but we did break it along the way. So we're now going to look at what would be the equivalent workflow that you would use with UV. And I'm going to hope that you're going to see that it's a little bit easier to follow and it's kind of less brittle. It's less likely to go wrong. So going back to our terminal, we've kind of reset now. If I look at what I've got in the folder that I'm in, I've just got myscript.py. We can have a look at myscript.py. So I'm going to cat myscript.py. Okay, it's the same file that we had there before. But the difference here, if you recall earlier, we had Python 3.10 already set up. I don't actually have Python at all on this computer that I'm simulating here. So if I type Python, I get an error. It's not found, I don't have it. So how are we going to set up Python using UV? We're going to start by going to the UV website. So I'll just pop a link to that in the chat now. You don't need to follow along with kind of trying to install it, but this is just to sort of give you an example. If you scroll down on the page that you get to on that home page, you get to this section that says installation, and there's a few different ways of doing it, but you select your operating system, Mac OS or Linux or Windows. So I'm using Linux in this case, so I'm going to use this command here. I'm going to click the handy copy button, and I can run that in my terminal. Now, I should just give you a little warning that you shouldn't normally run things like this that you find online, if you, especially if you find them in kind of help messages or things like that. What this is going to do, this program called curl is going to download this file called install.sh.shell, and then it's going to run that immediately. So whatever code is at that website will just get run on my computer. And you can imagine this is kind of like quite an easy way for people to get you to install malware. But in this case, we trust the people that publish UV, and so it's okay. We're going to go ahead and run this. So I've hopefully copied that. Yep, I had. I've now pasted that line into the terminal, and I can press enter and run it. That will download UV 0.6.11. I checked this morning. That's the current version. And then it will say, great, everything is installed. Then it gives us a little bit of a message to say, right, in order for it to work, because it's new, you need to restart your terminal. So normally that means you just close the terminal and reopen it again and everything's fine. For the purposes of the demo, I've got a little line that I have to run to simulate that. So, right, effectively, I've closed and reopened my terminal. So we're back to exactly where we were, just with this myscript.py. The first thing I'm going to run then, using my newly downloaded UV, is UV init, which stands for initialize my project. And I get to select a Python version by going ---- Python, and I'm going to choose 3.10. So very quickly, that's initialized a project. It's called it UV demo, the same name as the directory that I'm in. And if I ls to see what's now in this directory, right, a load of files have been created because I only had this myscript.py before. Let's have a look at what's been created. I've got this .python version, so it's a hidden file because it starts with a dot at the beginning. Let's have a look at what's in there. So cat.python version. It literally just contains 3.10. So it contains just the version of Python that I asked for right at the beginning. That's everything. I've got this file called readme.markdown, which is at the moment blank. And I've also got this example file main.py, which I'm not actually very interested in. So I'm going to just remove those. So rm readme.md and rm main.py. If it's a new project, these are quite good kind of starting places for you, but I don't need them, so I'm going to remove them. So right, we've got these 3 files left. I can now run Python, but instead of just typing Python, I type UV run. This is the standard pattern with UV that you don't have, you must type UV run at the beginning of everything, and you never have to activate the virtual environment or the environment that you have. So that's the change. So instead of doing this activate step, you would just ignore that and you type UV run. So I'm going to go UV run Python -V to check the version of Python I've got installed. I actually don't have Python installed when I ran that command. As soon as I run it, UV will go away and it will download a matching version of Python for, in this case, 3.10.16. It will install it and then it will run it, and I will get the command that I had, which is give me the version, and I get here Python 3.10.16. That's the current version. If I run that command again, UV run Python -V, you'll see it doesn't download Python again, so we just get that one line of output there. So now we haven't installed NumPy or SciPy yet, so I'm going to do that. So UV add is the way I get UV to install stuff. So it's the equivalent of kind of pip install. And I'm going to install NumPy. You don't normally need to put version numbers, but I'm going to put exact version numbers because I want to kind of match in with what we did earlier in the demo. So NumPy == 121.6 and SciPy version 1.7.3. Oops, and I need the double equals there to say exactly that version. So that is effectively what was in our requirements file before. So I run that, UV goes away, downloads those packages and installs them. I can run the script that I have to check that that works. So I can go UV run, and I could either type Python myscript.py, but because so often with UV you're running Python, if the file you're running ends in .py, you actually don't need to type Python. So I could remove Python here and just say UV run myscript.py. So let's run that. And we get the same output as before, that we were expecting this p-value of 0.021. Right, so what happened last time? I went, oh, I'm now going to do some plotting. I need to install matplotlib. So I'll do that again, but just UV add matplotlib. So this is where it went wrong before. Now, when I run that through UV, UV will go away and it will make sure that it installs a version of matplotlib automatically that matches the versions of NumPy and SciPy that I've got already. And you can see from the output exactly what version of matplotlib it installed. And if you remember, the version we ended up with before was 3.8.4. So we've ended up in the same place we were before, but it hasn't gone wrong at any point. And I can hopefully verify that by going UV run myscript.py. Great, we get the same output, a p-value of 0.021, but this time we've got matplotlib and there'd be no issues along the way. One last detail here. Thanks, Pau, for the round of applause that it worked. If we have a look at what is in this folder now, we've still got the .python version, we've got the myscript.py, and we've got this pyproject.toml, which we didn't look at before, but I'll show you in a second. But we've now ended up with .venv, which is the directory containing the virtual environment, and we've got this new slightly mysterious file uv.lock. So let's just have a little look at these files. Well, I've already shown you Python version, but I'll just show you again. Python version is just 3.10. Let's have a look at this pyproject.toml, which is toml, which effectively is like a kind of settings file. So it's fairly readable. This is the content of that file. It starts with this identifier at the top that says this is information about a project. It says the name of my project is UV demo. Here's a version. Here's a description. Here's the README file. All of these things you can customize and change. It requires at least this version of Python. So you can see greater than or equal to there. And in this case, in this Python version file, we chose 3.10. And then my dependencies listed here, matplotlib, numpy, and scipy. This is a bit like the requirements file that we had earlier when we were working with pip. You can see the kind of this equals equals and greater than or equals. That's the same syntax you use in a requirements file. Let's have a look at the last file now, this uv.lock file. So cat uv.lock. This file is much, much bigger and much more difficult to read. What it contains is a list of every single package that was installed in order to make numpy and scipy work. So in this example, here is a package with the name contourpy. So package contourpy. It's got the version of contourpy. It's got every different URL to get every kind of version depending on what operating system you're using that corresponds to that version. And if I scroll to the right, it also has these bits that say hash. These are cryptographic hashes of all of the downloads. So you can see here's a download for macOS version 10, macOS 11. Here are some Linux versions. The hash makes sure that it is exactly the same piece of software that's been downloaded. You can see some Windows ones at the bottom here. And then this file goes on and on and on and on. And it is just over 370 lines long, but you're not expected to read this file. This file is kind of equivalent if you've ever used pip, and I won't kind of type it here, but if you ever use kind of pip freeze and save that to a requirements file like that, pip freeze greater than requirements.txt, the uv.lock file is effectively the same kind of output that is in that file, but it's all managed for you. If you version control your project, say you use something like Git and you maybe push your files to GitHub, you should version control not the VM folder, that will get ignored automatically, but you should version control, if you like, the Python version, but definitely the pyproject.toml and almost certainly the uv.lock. There are some occasions when you wouldn't want to version control that, but if you're doing a kind of data science project, that's the kind of, you would probably want to version control Python version, pyproject.toml, and uv.lock. So I'm going to take just a moment's break just to see if anyone has got any questions so far. Feel free just to type them in the chat if you have. Pau has typed a question saying, it looks like UV can run on the user space without admin rights. That's right. So if you can download UV and run it, then it just installs automatically inside your own kind of home directory or profile on your computer. So if you are running on an HPC system or something like that, then probably this will work fine and you will be able to run it. There are kind of some edge cases. So if you work in a company that's got some kind of security software that doesn't let you download anything, then yeah, you're probably not going to be able to run it without permission. But in most cases I've seen you can. So yeah, thanks for the question, Pau. Right, so we're now going to look at configuring UV using this pyproject.toml that we've got here. So we can make changes either using the UV program. So we could type UV something, 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 or we can edit things like this PyProject file ourselves using a text editor. I'm going to do it at the in the command prompt here, but you could use like Visual Studio Code or whatever program that you like to use as an editor. The one file that you shouldn't edit by hand is this uv.log file. So you must let UV manage that file and not try and change it yourself. So the two things that I want to do now is I want to update the version of Python. As I said at the beginning, this version 3.10 is quite old. So I want to update that, and I maybe want to change the versions of NumPy and SciPy because they're a bit old as well, and I want to let UV upgrade them to something a bit more recent. I can first check what versions of Python are available by typing UV Python list. So that will go and tell me the different versions of Python I can have and the different versions of Python that I do have. You can see this line here, CPython 3.10.16. At the end of the line, it has a path here, which is somewhere inside my home directory or my home folder. And so that's telling me I've already got that one. But all the other versions, it says download available. So it says these are ones that I could have if I asked. Right, so I can see that, yeah, so 3.13 is in that list. So I'm going to tell UV to use that version of Python in future. I can do that either by editing the .python version file, or I can use UV Python pin 3.13. Right, so I get a little bit of warning here saying, okay, you don't currently have version 3.13, but it has updated the Python version file anyway, and I can check that. So cat Python version or .python version, and that file's changed from 3.10 to 3.13. Now let's edit some of the dependencies in the project. So I'm going to edit using nano the file pyproject.toml. So this is the same file from before, and I'm going to go down to this dependencies section here and make some changes. The two changes I'm going to make are for NumPy, I'm going to change the double equals. So that means exactly version 1.21.6, and I'm going to say greater than or equal to, so at least that version, but I've kind of relaxed the constraints a bit. I'll do the same for SciPy, so I'm letting UV upgrade those. I'm going to save and exit, and because I've made some changes manually, I have to tell UV in this case, right, I want you to upgrade the packages that you've got installed to match the new version of the file. And I do that by typing UV sync, and I want to allow it to upgrade the packages as well, so I go -- upgrade. When I run that, what we expect to happen is the version of Python to change and the versions of NumPy and SciPy to change. Right, so we could see very quickly version of Python being downloaded and then some other packages being downloaded. And now we've got version 2.2.4 of NumPy. We've got version 3.10.1 of Matplotlib and version 1.15.2 of SciPy. So everything has kind of been upgraded together. Let's finally check that that works. UV run. I don't need the Python. I can go straight to myscript.py. Phew, there was a little bit of a delay there, and I was a bit worried, but no, we had the correct answer, 0.021. So what I'll come on to now is, okay, this is kind of great as an example, but how might this apply in a data science project context? So how might you actually use this? Well, the danger continues because there's more live demo. I'm now started afresh, but what I've done just to kind of accelerate things a bit, I've already installed UV and I've already gone UV init like I did before, but this time I just put one extra thing at the end. I put -- or -- lib, which says that I want a library to be created, or effectively a package to be created. I'll show you what that means now. So let's have a look at what I have already created and use tree, which will give me a little kind of breakdown of what's in the folder. We've got a README file. We've got these two files, pyproject.toml and uv.lock from before. And then we've got a Jupyter notebook, example notebook here inside the notebooks folder. And then we've got a folder called source. In there is a folder called my project. So it's 2 folders deep. That is the name of the project that I've created. And then inside there, I've got this file probability.py. So the first thing I'll do is I'll show you what's in that probability.py. That's the main bit of code here. So cat source / my project / probability.py. That is pretty much the same code that we had before. So we've got the import from SciPy of this binomial test function. We've got all these print statements that we had before where we're kind of working out is our coin biased. But the main difference is I've just put everything inside a function. So it doesn't run the code when you run the file, it just defines the function. And this in my silly example here, it's not particularly useful, but if you've got a data science project, this is a very good thing to do because all of these functions that you end up putting your code inside of, you can run separately and test that they work properly. And that's the kind of the way to make your code more robust. So that's the main change in that file. If I have another look at this pyproject.toml file here, so cat pyproject.toml, it starts much the same as before. So we have some metadata about me and about the project. We have a minimum version of Python, 3.12 in this case, and the dependencies that we're using in this project. So the kind of familiar NumPy and SciPy. But then if I scroll down to the bottom, it's not that much longer, but there's a few added things here. First of all, I've got this extra set of dependencies here called development dev. Here I've specified IPyKernel, which is a thing that it's useful to have if you want to use Jupyter notebooks and you want to use them from VS Code. So that there is installed or will be installed, but it's in this dev group here, which is kind of a more advanced thing. But what I'm indicating here is that this is useful for when you're writing the code, but actually this isn't really part of the code. It's a kind of helper package. I've also got this section called build system. Now, it's not immediately obvious what this is, but this is what ensures that inside that source directory, src, that we had earlier, that becomes a package that I can use inside my project. This might all sound a little bit confusing, but we'll come on to a kind of a concrete example of what that means. And then the final thing here, which is new, we've got this section called project.scripts. And in here, we've got one script defined called testcoin. And what that will do is it will create a command that we can run at the command line that runs some of our code kind of as a shortcut, as an alias. What does it run? Well, it goes into the my project package. There's a dot here, so it goes to the probability.py file. There's no .py there, but it's kind of implicit. And then there's a colon here, and it runs the function testcoin from that probability.py module that we had. So that should do our binomial test. So back at the command line, I can give you an example of that one straight away. So I can type uv run test-coin. And then we get the kind of familiar output that we've had before. But I haven't had to kind of know what the file is. If you've got lots of files inside your data science project, this is a really kind of useful way that you can collect things that are run often together and give them really easy to remember commands. And then you could put these inside your README file for new users to say, okay, first run download data, then run pre-processed data and things like that. So you can kind of imagine what that might look like. Now I'm going to install, now I'm going to look at the notebook that we had there. So if you recall, there was this example notebook inside the notebooks folder. And this will show off one of the features of UV I mentioned right at the start was that it's very easy to create these kind of throwaway virtual environments, add packages, remove packages. It doesn't take any time at all. So I'm going to type this command and then explain it afterwards. So uv run -- with Jupyter space Jupyter lab. Jupyter with a T, lab. Now, the way to read this is to say, right, it's uv run, and what am I running? I'm running Jupyter lab. So that's the command I'm running, which if you're used to running Jupyter Lab or Jupyter Notebooks from the command line, you'll recognize that as the command that you run. But this -- with here is my way of saying, right, I need you to temporarily add this package to the virtual environment. So that isn't in the pyproject.toml, but can you kind of assume it is in there, run Jupyter Lab, and when we finished, just get rid of Jupyter. So this is a really kind of neat way of kind of just temporarily adding something. So I'll run that command. It goes away and it installs Jupyter Lab, downloads it, installs it, and then it runs it. And again, if you're used to Jupyter Lab, this kind of load of stuff at the beginning is quite familiar. I can click on the localhost link I get here. And then fingers crossed in my web browser, we get Jupyter Lab where my Jupyter notebooks will be. So I'm just going to make everything a little bit bigger, go into my notebooks folder, into my example notebook. And you can see my notebook's fairly basic. First of all, I've got a little bit of markdown introduction, and then I say from my project import probability, which if I look back on the left-hand side into the source folder, you'll see this is the my project that is referring to. And then this is the probability.py that is referring to. So I'm going to open probability.py just so we remember what's in it, and I'll just put it on the right-hand side, and I'll make a bit more room by closing the file browser. So I can run that command now. Oh, sorry, run that cell with that command in it. And I didn't need to make sure that the probability.py was in the same folder as the notebook. I didn't need to kind of mess with file system paths and Python path if you've ever done it that way before. Basically, because of the way that I've set up that pyproject.toml with UV, this is all automatic. So I can access this code on the right-hand side inside my notebook. There's then a really useful bit of magic that I would recommend you doing if you do it this way. I use this extension called auto reload and then auto reload complete here. There's % at the beginning. Can run that cell. What that will do is if I was to go in and change my probability.py here, it would automatically re-import that file for me. So I don't need to restart the notebook or anything like that. So finally, the last cell here, probability.testcoin, I can run it and I get, okay, yeah, the same output we're used to. Maybe as part of the demo, let's say I flip the coin 20 times. So I'm going to change 10 to 20. And then in the binomial test, I need to change n to 20, but we've still got, should be a fair coin, and we've still got its one head is observed. So I can save that file now. So Control S. And then inside the notebook, I can rerun just this cell here. And you can see it's automatically now reflected the new probability.py. So now we flipped it 20 times. What's the probability of this happening if the coin was fair? Well, 0. So this is incredibly unusual. We're saying like the coin is definitely biased. Right, so because of time left on the talk, I am going to skip to just showing you a couple of kind of really quick demos. I'm going to come out of my Jupyter Notebook and Jupyter Lab here and go into a second demo. Right. So in this demo, I just have, again, myscript.py. If I look at myscript.py here, so let's cat that, looks pretty much the same as a normal script, but I've got this special block of comments at the top, which UV can manage for you. So this is saying requires Python 3.12, and then it has some dependencies, which in this case is just NumPy. I haven't set up a virtual environment. I don't have a pyproject.toml. I haven't done any of that. All I'm going to do now is go UV run myscript.py. UV automatically installs NumPy for me. That was the kind of output and a little progress bar you saw there. And then it runs the script, which in this case just reports NumPy version, whatever the version of NumPy is. Here I've got 2.0.0, which matches what I asked for at the top. If I run it again, UV run my script, doesn't need to install NumPy again. I instantly get the script to run. This I would recommend you looking at if you want to sort of send demos to other people. It's really useful for demos, for recreating bugs, or for kind of like sharing, oh, this is a really good way of doing things. Because usually whenever you share those snippets, someone will go, oh, well, this doesn't work in my version. It says I don't have this package. What do I need? Well, this is a great way of just encapsulating all of that information at the top of your script file here. So in summary, and I can see some more questions in the chat, so I'll have a look at those in a second. If you want to find out more, then just go to the docs website for UV. And if you were interested in Pixi, you can go to their website for docs as well, or come to the talk that we're running later this month. This is a little bit different from using pip, but I would recommend using it for new projects. I mean, I've now started doing it for most of my projects, and I find it kind of really rewarding that I can kind of forget. I don't need to worry about this kind of requirements.txt anymore. I'd also actually recommend it if you're working with someone who's new to Python, because this kind of UV run thing that we were doing, especially where we had the kind of inline requirements at the top of a file, this is actually quite useful for working with people. People don't actually need to install Python themselves and go through that pain. If you can get them to install UV and then basically type a command at the command line, everything else will happen magically for them, which I think is quite kind of useful when you're working with people that kind of aren't as confident with coding. And then the final thing that I hope you kind of get from this is that just be very careful if you're ever using pip or in the case of the next talk, conda by themselves, because you can kind of run into these sorts of problems that we demonstrated earlier on. And that's one of the things that UV is trying to do, is to try and reduce the likelihood of that happening. If you do want a copy of the slides or want to watch a recording of this talk, I know we're recording this talk now, but there's also a recording of the previous version of the talk that I did, and that is in the link that's just gone into the chat now as well. So if anyone has any questions, please feel free to ask in the chat, and yeah, I will stop sharing. Yeah, feel free to ask. I've got some already that have come in. I can see people typing as well. So Pau said, can you update the Python version in the TOML file without editing .python version? You can, so you don't, so the .python version file is kind of, that is the version that you're using at the moment. You can actually just delete that file and effectively just use the .toml file to define the version of Python that you want. The version by default in the pyproject.toml is always done as a greater than or equal to the current version that you're using, but you can actually just, like you say, you can just change that to be whatever you want. And then another question in the chat, is the %auto reload called after importing the library, or can it be added at the very top of the notebook? I tend to put it through kind of personal preference. I tend to put it after, because when I read through the notebook, I kind of think, right, let's import all the things I want. And then I say, by the way, I'm updating these things if I make changes to them. But I'm pretty sure you can just put, the order doesn't matter. I think you can just put it wherever you want, but feel free anyone to correct me if I'm wrong on that. And another comment at the bottom, what do you mean by don't use conda pip by themselves? So I'll go on pip specifically. Yeah, thanks for the question, getting me to clarify. So at the beginning of the talk, we had that demo of just using pip, and it is perfectly possible to use pip in a way where you're never going to get caught in a mess. You can make sure that you update your requirements file. You can make sure that you version control that requirements file. You can make sure that every time you install new packages, you refreeze a version of that requirements file and you version control all of that. And as long as you kind of follow all those steps, you'll be fine. But what I've just described is like 4 or 5 manual steps that you need to do. Whereas if you use a tool like UV, or there's another tool called Poetry, which is quite similar. All of these tools kind of do a lot of, they basically automate a lot of those steps for you. Now, if you're quite familiar with your project, for you, it kind of doesn't matter the way you do it, because you're probably not going to go wrong. But as soon as you start working with somebody else, and I've worked with other people on projects where there is a requirements file in the Git repository that I use. And okay, so the first thing I do when I come onto the project is I create a virtual environment. I install the requirements file, run the code, it immediately fails, and it says, well, you're missing some requirements. And then I kind of read through the code manually and I go, oh, well, there's this other package that, maybe they've installed more recently and they've forgotten to update the file. And then I run that, and then it still doesn't work because the versions in the requirements file are wrong anyway. And I have to kind of talk to the person and manually try and work out, well, what versions do you actually have? Oh, there are some things you installed that you don't care about anymore. And what I quite like, and I'll go back to one of my demos here. So that's the wrong one. So let's go back to UV, the lib demo. So this kind of the big data science project that we had, and that looked like this. If I look at these two files here, the pyproject.toml and the uv.lock. So in the pyproject.toml, I know in this file the versions of the software that I kind of intended to use. What was my intent? Well, I wanted Python, and I wanted at least this version of Python, and then I wanted NumPy, and then I wanted SciPy, but I didn't really care about the exact version. I just wanted them to be recent. And then I also wanted to use this ipykernel file. So these lines here, that's my kind of intent. That's what I'm using. If someone comes to my project and says, right, what are you using? That's my answer. If I look at the uv.lock file instead, this is really, really, really long. This is exactly the versions of everything that lets someone hopefully recreate the output of my code exactly. But have we ever heard of a package called appnope version 0.1.4 or AST tokens version 3.0.0? If you were to read through this file, which is kind of the equivalent of a pip freeze, I can probably try and show you what a pip freeze would look like. Yeah, so if I was to be using pip and doing pip freeze, I'd get this file. And okay, it's not that long. It's only got 31 things in it. But again, like it's unhelpfully in alphabetical order. So actually, the only things we actually wanted were, I remember, like NumPy and SciPy down here, and at one point matplotlib as well. But you don't see that from reading through this file because there's just too many things there. Hopefully that answers your question. Just let me know if it doesn't.